Hi, I'm Kurosh Latvizadeh. I'm the operations manager over here at the UC San Diego shake table facility. Basically, we're an earthquake simulator. We have a large shake table platform here where we can build test specimens on and replay earthquakes that have happened in the past and test different aspects of the buildings to see how resilient they are to earthquakes. So why don't I show you how it works when we go inside right now. All right, so now we're in the control room, and this is where we operate the shake table. This is where I come when we want to start the simulations replaying earthquakes. All the controls are over here, so we have everything we need to simulate earthquakes right here. We have our emergency stop and our joystick for slowing down the system if needed. All right, here we're at the accumulator banks. We have 75 large bottles. They're basically pistons with nitrogen fill on one side, and we pressurize oil at the other side of the piston. We typically keep the pressure of the oil at 5,000 psi, which is roughly 156 times the pressure that's in an average car tire. So in each of these bottles, the 75 of them, we fill oil. And we keep that oil at high pressure, and when we need it to replay an earthquake, we shoot that oil through these very smart blowdown manifolds, through the large red pipes, out into the system, and that is what causes the actuators to move the way we want them to. So each one of these bottles, since they have high pressures inside them, we need to make sure that we're monitoring the pressure, the temperature, and different factors. So each one is outfitted with these wireless sensors that monitor the pressures and the temperatures, etc., that we need. They also have an analog gauge that shows us, for visual inspections when we're coming through here. But these wireless sensors take readings very, very frequently at regular intervals, and they send it to a database where we can visualize and track over time the pressures and temperatures that are of interest for us. This helps us monitor and ensure there's no leaks. And if there are leaks, we can catch them early and actually solve the problem before it becomes a major disaster. All right, let's go show you the pumps. So here we have the two large pumps, hydraulic power units. We call them HPUs for short. We got two HPUs here, two on the other side of the accumulator banks that we were just standing at. And these pumps each have two motors and a heat exchanger that apply that pressure to the oil inside the accumulator banks. They store the oil at 5,000 psi. So now we're going to go downstairs, and I can show you where the oil goes from the accumulator banks to the actual shake table. So here we're at the base of the accumulator banks where we were standing earlier. You can see just how massive these bottles are and how congested this area is with the piping. These large red pipes are what carry that high pressure oil out to the shake table. These are about 12-inch inner diameter. They're over an inch thick. So anything you see in red is high pressure. It's very dangerous, so we don't typically allow anyone down here when the system is actually on. So the red pipes take the high pressured oil to the system. When that pressure is released and used within the actuators, the low pressure oil returns through these large blue pipes. So the color coding stays consistent throughout the entire system. All right, follow me. We're going to go into the actual shake table and see what's underneath. What's happening, man?
How's it going?
Good, how are you? Wow. So right now, we're actually underneath the shake table. This is the platen where that large building that you saw earlier is sitting on top of this. This whole steel platform is what moves and reproduces an earthquake. This is the shaky bits of it. The whole thing is powered by two large horizontal actuators in a V shape over my head here. There's a mirrored image on the other side with two other horizontal actuators on the other side. We have 6 vertical actuators, 3 of them in line on the south and 3 of them in line in the north side. And the vertical actuators allow us to move the table up and down. We can do the roll and the pitch, so we can do those different degrees of freedom. And the horizontal actuators give us the ability to move, back and forth, left to right, and also some yaw motion. So here we're standing next to one of 6 vertical actuators, this guy right here. It's a really large 32-inch diameter pressure balance bearing. Each one of these are outfitted with a high flow servo valve right here, where what actually directs the fluid into the actuator and tells it, to go up or down or whatever we need it to do. The top of this surface that mates with the platen glides over these actuators. They're not actually attached to one another. The platen is just sitting on top of this, applying a downward force on it. The top surface of this pressure balance bearing looks very much like a pizza. It has a crust and it has little slices, grooves inside it, where oil comes out. It fills the inner chamber, basically the inside of that pizza crust, with an oil vacuum. And that mates to this very precisely machined steel plate, what we call the glide plate. And that oiled, lubricated surface allows the platen to slide freely on top of this pressure balance bearing and let the shake table move while still being able to push it up and down and perform those other displacements that we're looking for. All right, so let's walk back to where we were. So to give you an idea of a little bit of the history of the shake table facility over here, the shake table was built in 2002 to 2004. It was completed around that time. And it was originally built as a single degree of freedom, where we could only move the shake table in the longitudinal axis. It was always designed with the 6 degree of freedom capability in mind. In fact, when this place was designed, they had already put the corner actuator mounting plates ready for this V-shape configuration. But due to funding restrictions that they had at the time, it was built with only a single horizontal actuator here along this middle wall and another one on the opposite side. Whereas now we have this V configuration on both sides. Similarly with these vertical actuators, the pressure balance bearings, they had the right bearing, but it wasn't powered. So the addition of these servo valves and the massive amounts of pumping power and the accumulation, we're now able to have that vertical displacement, the pitch and the roll as well. So early next year, all of this machinery is going to be in use when this building is completed. We're going to start testing this. We're going to simulate earthquakes and shake this thing. So it's going to be very exciting to watch. Thank you for coming.